Good morning. We are looking at word problems for our rational equations now. So we have to write our own, and then again, we're still following those same steps of 1 is identify the least common multiple, 2 is to multiply by that least common multiple, then we simplify, and we solve for our variable, or in this case, whatever the problem is asking us to find. So starting with number 1, I've got a plane that is flying at a speed of 300 miles per hour in still air. We need to find the speed of the wind if a plane went a distance of 680 miles in a tailwind and 520 miles in a headwind. So remember, a tailwind means that if I have my airplane in a tailwind, the wind is helping the plane. And in a headwind, we're flying against the wind and it's kind of hurting the plane. It's negatively affecting our speed. It's slowing us down. So those of you in physics might be familiar with these equations already, but if you're not, time can be written as the distance you travel over your speed. So our plane that traveled 680 miles per hour, or sorry, not per hour, 680 miles in the tailwind was traveling at a speed of 300, that's still air speed, plus the speed of the wind. And when we were in the headwind, we went 520 miles per hour. Again, this is our still air speed minus the wind. The wind is hurting us here. And we're told that these two times are equal. So this is how we're setting up our equation. And now we're going to go through our 4 steps. So we're going to identify our least common multiple. And that is going to be 300 plus W times 300 minus W. So then step 2 is multiply that on both sides. All right, and now we are on step 3, which is simplify. And now we are ready to solve. So we're going to distribute and solve for W here. And these are going to end up being pretty large numbers. So we're going to get 204,000 minus 680W is equal to, and I'm running out of room here, 156,000 plus 520W. Sorry, that's kind of small. So we're going to get all of our constants on one side, all of our W's on one side, and we're going to get that 48,000 is equal to 1,200 W. So we divide, and we get that the speed of the wind is 40 miles per hour. Now, I'm going to come back to number 2, and you'll see why after we go through the rest of these problems, but number 2 will make more sense if we do a different problem first. So I'm going to skip ahead to number 3. A manufacturing plant produces X units for a cost of $26 per unit plus an initial investment. How many units must be produced for the average cost to equal $30? So our cost is that $26 per unit plus our initial startup investment. So 26x plus $80,000. That's our cost. Our average cost is going to be the total cost divided by the number of units. And I want this to be equal to $30. So here's our equation. Now to solve it, I need to first identify my least common multiple. That's just going to be x. Step 2, multiply by that on both sides. And this one's actually going to be a little bit easier. So we simplify, and I get that 26x plus 80,000 is equal to 30x. And now this is just a 2-step equation. And 80,000 is equal to 4x. If I divide both sides by 4, I get that x is 20,000 units. Number 4 is similar to number 1. This time we're talking about a boat. So a boat has a speed of 60 in still water, and then we have a distance that was traveled upstream. So this is where we're fighting the current. And then it travels 13 miles downstream. So this is when we're flowing with the current. And this again is happening in the same amount of time. So remember, time is equal to your distance over your speed. So when we're fighting the current, we have traveled 11 miles per hour, and our speed is that 60 miles of the boat minus the speed of the river or the stream, whatever you want to call it. And when we're flowing with the river, we're traveling 13 miles per hour at a speed of 60 plus the river or stream. And these times are the same. So again, identifying our least common multiple, that's going to be 60 minus r times 60 plus r. So then step 2 is to multiply each side by that least common multiple. And then step 3 is to simplify. And now we're ready to solve. So we are going to distribute and solve for r. And get all my constants, get all my variables together. I get that 24r is equal to 120. Divide by 24 on both sides, and we get that the speed of the stream is 5 miles per hour. All right, number 5. One person can complete a task in 6 hours. A second person can complete the same task in 4 hours. How long will it take them to complete the task if they're working together? So I've got 2 people. The speed of my first person is 1 task every 6 hours, and the speed of my second person is equal to 1 task every 4 hours. So if I'm wanting them to complete 1 task together, that is going to be the speed of the first person times the amount of time that this is taking plus the speed of the second person times the amount of time that this is taking. So time is the same in this scenario, and I know what each speed is because I've just written it out. So that's going to be 1/6 t plus 1/4 t is equal to 1 task. So the speed times time plus the speed times time equals the number of tasks completed. Now, these are like terms, so I can add them. 1/6 plus 1/4, you can do that by hand, getting a common denominator, or just type it into your calculator. And you're going to get 5/12 t. Now, t is what I'm solving for, so I need to get t by itself. If you already recognize that you can just multiply by the reciprocal, that's great. If not, you'll just need to do this one step at a time, first by canceling your denominator. So 12 is equal to 5t, and then divide. And we get that time is 12/5 of an hour, which is approximately 144 minutes. So now that we've done number 5, number 2 is going to be a bit easier to complete. So we've got a cold water valve open that takes 8 minutes to fill the tub of a washing machine. With both the hot and cold water valves open, it takes 5 minutes. How long would it take to fill with just the hot water valve open? So this is similar to number 5, but we're working backwards, sort of. So the speed of the cold water valve is 1 tub filling every 8 minutes. And the speed of the hot and the cold water valve is 1 tub every 5 minutes. And these valves working together to fill 1 tub is going to be the speed of my cold valve times time plus the speed of my hot valve times time. And in this case, I know the speed of the cold water is 1/8, and I know that time is 5 minutes. I don't know the speed of the hot water valve, and I know that time is still 5 minutes. So I'm solving first for h. That's the speed of the hot water valve. So that's going to be 1 is equal to 5/8 plus 5 times h. If I subtract 5/8 on both sides, I get that 5h is equal to 3/8. So if I divide by 5 on both sides, I'm going to get that the speed of the hot water valve is 3/40. Now remember, speed is 1 tub over the amount of time that it's taking. So this speed is equal to 1 over the amount of time. So if I'm still looking for time, I'm going to need to take the inverse. So you can do this by, step by step algebraically. 1 is equal to 3 over 40t, or if you already know how to find the inverse, that's great, go for it. But we're going to get 40 over 3 minutes, which is about 13 1/3 minutes. And that is those 5 word problems for continuing our solving rational equations.